class, welcome to 9.4, hypothesis test for a single population proportion. Right, here's example number 1. It says a consumer group asserts that the proportion of households have 3 cell phones is 30%. A cell phone company has reason to believe that the proportion is more than 30%. Before they start a big advertising campaign, they conduct a hypothesis test. Their marketing people surveyed 150 households. With the result, 60 of the households have 3 cell phones. This data is used to test the claim that more than 30% have cell phones. At a 5% level of significance, is there sufficient evidence to support the company's claim? All right, so let's start off with the populations here for this section, a little bit different than 9.3 when doing that for the mean, but pretty much the same premises here. Population number 1 is the experiment group, and population number 2 is the control group. So here we want to identify the sample and looking at the company versus the consumer group here. So let's go ahead and outline here. Before they get started, where did that 150 household that came from a big advertising campaign? And identified those cell phones versus what we're going to look at for a cell phone company. So from the first sentence, let's go ahead and highlight that. A consumer report asserts that proportion of households have 3 cell phones is 30%. That's 30% of that population. A cell phone company has reason to believe that the proportion is more than. So a cell phone company wants to prove that's true. So we're basically going to break this down that the second sentence here is going to look at identifying with population number 1 versus sentence number 1 is identifying with population number 2. All right, so for both of these groups, we have the set of all households that obtain those 3 cell phones, that have that nothing more, nothing less. They specifically have only 3 cell phones in their possession. Okay, again, set of all households that have 3 cell phones, THR, 3 cell phones. Okay, let me back up just a little bit here. Let's copy that for the second group. Both of those statements are the same, identical for both groups. So let's go back and highlight what is happening for population number 1. Again, I want to iterate that was for the second, that was obtained from the second sentence. A cell phone company is reasonably the proportion is more than 30%. Versus population number 2, the control group, was the consumer group. So here, for the population number 1, the set of all households that have 3 cell phones by a cell phone company versus a consumer group. I'll just abbreviate that, GR. Now that we have that established, we can go ahead and put our proportions. I'm not using mu here in this case, we're going to end up using the value P, that is the population proportion, the symbol used, that's for that first group. So P sub 1, kind of similar to what I did in the previous section, 9.3, I used mu 1. That identified with population number 1. That P identifies with population number 1 here. P sub 1, P, not to get confused, but more or less I'm outlining the fact that I'm taking the number 1 here goes along with this number 1. Versus I want to compare that to, I'm going to say that's equal to the population proportion for population number 2. But we want to show it's more than that from the researcher, more than that for population number 2. So when I identify 2, I'm meaning that for the 2 there, that number 2, and that number 2. However, in this case, we know the researcher wants to show or is identifying that P2 as the 30%. So that 30% is P sub 2. I can go ahead and erase that number and substitute that with that value there. This is going to help out really well when we get to multivariate, because there are going to be a lot of P sub 1, P2, P3, P4. This is going to get a little more abstract. But here for this example, we know what that percentage is. 30%, 30%. If you want, you can use 0.3 instead of the 30%. Now that we have that established, we can go ahead and look at the requirements and then determine the sampling distribution being used. So let's outline that number 2, part A, the requirements. So the requirements are what we looked at for a confidence interval that was n times p hat was greater or equal to 5, and here, and n times q hat is greater or equal to 5. But in this case, it's not the p hat. The p hat is not on trial, the 30% is. So what I need to do is erase that and go along with the alternative value. I want the P2, and the complement of that will be Q2. So what we're really looking at is the sample size taken here. So with this example, they took, let's look back here up at the prompt again. What was the sample taken? So here for the marketing people surveyed 150 households. So what we want to do is take that sample size and multiply that times that claim. So I'm going to take the 150 and multiply that times 30%, 0.30. And then for its complement, the complement of 30%, 100 minus that would be 70. So 150 times 0.70. Let's go ahead and grab a calculator and multiply that together, figuring out those values. First, we're going to take 150 times 0.30. We should get the number 45. There's the number 45. That meets that requirement. That's greater or equal to 5. Perfect. Its complement, let's go grab a calculator again. Take 150 and multiply that times 0.70, and we get 105. Both of those meet that requirement. 45 is greater or equal to 5, and so is 105. Perfect there. Therefore, we can imply for part 2B, 2B is the sampling distribution, which will be the standard normal distribution for a population proportion. Standard normal distribution. Okay, we've met the requirements. We do that. We're going to go ahead and slide forward to part number 3 here to determine the cutoff score for significance. But just to point out, you've got to meet the requirements. If that wasn't met, you have to increase your sample size in order to meet those requirements there. So let's go ahead and move forward now to part 3 here, figuring out the cutoff point for significance. Here to point out here, on trial in the center is that claim, 30%. What we're going to try to do is reject the claim, showing that from our cell phone company pointing out it is significantly more than the 30%. What is significant in this case? We know that significance is that level of significance. Let's go ahead and find that up there at the top. There it is there. We know that we have a 5% level of significance. Perfect. And as a decimal form, we know that's equivalent to 0.05. So alpha is equal to 5%, which is equivalent to 0.05. Then the next question is this a left tail, right tail, or two-tail test? Let's look at the research hypothesis. So back over here, the research is showing they want to show it's more than. That's an arrow pointing to the right. This is going to be for a right tail test. And then finally, the last part there is to go and bring this information together. We don't need to know what the degrees of freedom is, because all that stuff with the standard deviation is settled. We're assuming here that the mean is equal to 0 and the population standard deviation is 1. Those settings on GeoGebra or whatever calculator you end up using, you need to keep that as 0 and 1. So we don't want to change that. But here, just to point out for the right, we're going to grab the bracket opening to the right there and choose for that right side. All right, so let's jump back over to and choose here for the GeoGebra calculator. Open that up, choose probability. If you're on the website, you'll choose under apps there probability. And then the first thing that's going to come up should be the standard normal distribution. All right, there it is there. So we've got normal, 0 and 1 for the parameters. Let's go ahead and choose the right bracket. And that bottom box to the right needs to be that level of significance, 0.05. There it is there. That middle box there, 1.6449 is a cutoff score for significance. So anything past that point will show statistical significance, 1.6449. Right tail pointing to the right, and that right side represents our 5%. Any point standardized past that point will show significance. So this will be equal to Z0. So that's our answer for step 3, 6.449. Now it's done for step 3. Let's go ahead and move forward with the sample taken. So for step 4 here, let's go ahead and write down all of the necessary statistics. For this, we have to know what the sample size is, and we've gone over that. We went and surveyed 150 households. Also, p hat is equal to, we're going to figure out that's going to be 40%. Let's go back up there at the top and grab that from the sample being taken. So the results here, it says their marketing people surveyed 150 households and resulted that 60 of those households had 3 cell phones. So we know that proportion is 60 over 150. We get bonus points if that's not a repeating decimal. Let's go ahead and divide. Take 60 divided by 150. And we get 40%, even, good to go there. We'll keep that as a decimal. By the way, we're not going to use it. We're going to iterate that from Q hat. When we do that for a confidence interval, that was 1 minus P hat. So that would be 1 minus P hat, which would be equal to, of course, we're looking at the complement 60%, 1 minus 0.40 is going to end up being 0.6. We're not going to need to use that. The only thing we want to emphasize is strictly on standardizing the 40%. So the formula associated with that, let's go over to step 5 and standardize that for Z. The formula is going to be P hat, that 40% there, so let's write this down. Folks, let's write that down. P hat minus the claim P2, population portion for P2 there, for population number 2, divided by the square root P2, not P hat. P2 times its complement, Q2, divided by N. So the claim, we just got that. That was from the initial beginning. We know that's going to be 30%, 0.30 as a decimal. We just grabbed the P hat there. That was the 40%, or that 60 over the 150. So 0.40. And then underneath there, you want to grab that P2. That's going to be the 30%, 0.30, times its complement. We use that up above, 0.70. And then underneath there, that N is, of course, the sample from 150. So let's go ahead and fill in the blank here. Grab a calculator, use parentheses for both the numerator and denominator. All right, for the numerator there, we're going to take the 0.4 minus the 0.60. We get negative 0.2. That's, all right. Looks like I made a mistake. Let's try it again. It should have been positive there. I don't know what happened. All right, let me start over. 0.40, so open up with a parenthesis, 0.40 minus 0.30. We get, good, 10%, 0.1. Now what we're going to do is divide that by the square root. I'm going to end up taking the square root of that. Let me back up just a little bit. Yeah, so let me start off with parentheses, then I'm going to root that. So it'd be 0.3 times 0.70 divided by 150. Now what we're going to do is square root, close parentheses, square root that, and then equals. So I did this on a very primitive calculator, ran it to the same number of places there, 0.26726. If you've got a graphing calculator or something on your computer, like Google Calculator, something of that nature, even some of these more common calculators are pretty good. On something like this, it may be hard to do. So I've got my recommendations there on the syllabus that I recommend for this. Well, let's just go write this down. So 2.6726, round again, the same number of decimal places that we got from GeoGebra. Okay, and that's the answer for that point. Now what we want to do and see, let's go back to step number 3 and see, is this significant? Is that in the rejection region? Right there. It's just right there between 2 and 3 standard deviations. It makes the cake. We're able to reject the 30%. So at that point, I know where to place the 40%. The 40% is significantly more than 30%. I can reject the claim at this point, and that's what I want to do at the last step for step number 7 is reject the null hypothesis. Now, that being said, I want to do the same thing and do a right tail test using that same number from step number 5. So let's go back over here to step 6. Find the probability for a right tail test that Z is more than the same number, 2.6726. Let's put that back into GeoGebra to find that answer. Okay, there it is there. For the bracket open to the right side, we're going to place back in that value from that step, the 2.6726. Click back there in that bottom right box, the 0.38%. That's definitely less than the level of significance. We're able to reject that. So we know that we have a 5% level of significance. That's under 1%. We've done our job there. So let's jump back over. We know that that value is again here, 0.0038. That's the p-value, aka 0.38%. Definitely less than the level of significance at 5%, and we can conclude the same thing of rejection of null hypothesis. So both step 5 and step 6 both agree that we can reject the null hypothesis. Therefore, we have enough evidence to show here from this step that we can reject that it's equal to 30%, that we have enough evidence to reject that, showing that it's significantly more than that. And that will conclude this problem here for problem number 1, section 9.4, hypothesis testing for a single population proportion.